Hello everyone, thank you for joining us today for our IIoT or PLC vibration monitoring, which is right for you webinar. I'm Bryce Brewer. I'm a product engineer at Grace. I cover the IoT line, working with engineering to look at new technologies and bring those to bear within our GraceSense line, as well as working with our customers in the field to develop solutions. And I'm joined today with Isabel here, so if you can introduce yourself.
Yeah, hi everyone. Thanks for joining us. I'm Isabel. I'm a firmware design engineer here at Grace on the GraceSense product line. So what I do is design, test, and maintain what we call the GraceSense operating system. That's the firmware that runs on all of our hardware, our cloud gates, control gates, and VBTs. And additionally, I designed what we call our edge processing firmware that runs on our stream processing engine. So it's a dedicated microcontroller that gathers all of the acceleration data and does all the computations on the VBT before we send everything out to the cloud.
Great. And so just to give you an overview of the products we're going to be talking about today. So we have our vibration temperature node here that would sit out on your motor, your bearing, gather triaxial acceleration data, and then as Isabel mentioned, process that and send it to a gateway. The unit we have here today is a combo gate, so it has a cloud connection as well as a PLC connection. And so we're going to kind of use those as a starting point, but we'll definitely get into more details on that as we move forward. So Isabel, if you could give us an overview of what we're talking about today.
Yeah, so today our webinar will have 5 sections. So we're going to start with Bryce telling you a bit about why would someone want to monitor vibration. And then we'll present to you several usual vibration monitoring methods that are out there. And then we'll give you a demonstration of our system. With the motor on the table running and how you set up our websites, how you monitor data through it. And then finally, Bryce will give you a demonstration of our Rockwell add-on profile feature. And we'll end up with a Q&A session. You guys feel free to ask any questions in the chat, and Nick here will collect them all, and we will make sure we answer you at the end of the webinar. And also keep in mind that it'll all be recorded, and you'll be able to watch this webinar again as part of our library of on-demand videos.
Great. So before we jump in here, we do have a poll question. So are you an end user, systems integrator, or are you in distribution and sales? So we just like to get that information to where we make sure that we're catering our content to who is attending our webinar. So hopefully, end users find out about the various solutions out there and where, they might be a good fit within their facility. The systems integrator might be looking at expanding their options and getting into vibration monitoring as a solution they can provide to their customers. And then distributor and sales folks, just to get more knowledge on this space in general, as well as, the solution that Grace offers to be able to go in front of customers and be able to provide value in a vibration monitoring solution. So it looks like we've gathered those up. Nick, what was our results there?
Yeah, about 24% are end users, 23% are system integrators or OEMs, and 35% are sales and distributors. And then we have 18% just wanting to gather some more information.
Okay, great. Yeah, so it looks like a decent mix. So hopefully everyone can find pieces in here that are of value to them. So we're going to go ahead and dive into why vibration monitoring in general. Why do we do it? So the key thing is, as we all know, motors are the heart of the plant. So if you have motors that go down and they're critical to your process, you just don't have any production. So then you have to bring those back online if it's unplanned. That can take time to figure out what the problem was and get the replacement parts. So we want to be able to know that something's happening before it does happen so we can plan accordingly. So with that, motors and bearings fail somewhat randomly, it would seem. So they don't just fail on a scheduled interval where you can just go ahead and, at 2 years I'm going to replace the bearing because it's going to fail soon. You just don't know that without some type of vibration monitoring or some other kind of monitoring system on that asset. So you could have, some set of bearings in your facility that run for seemingly forever. You never had to change those. And then you can have some that you just changed 9 months ago, and you have a failure due to maybe it wasn't quite aligned properly, or some other issue with that particular asset. So.
Okay, so something I hear often is you can monitor the current that your motor draws and the temperature of it. Mm-hmm. Is that, what do you think of this as a way to monitor the situation and the health of your motor?
Yeah, so definitely current and temperature can be used to determine the health of a motor. The hard thing with those, though, is when it gets a temperature increase or current draw increase, that's going to be later in the cycle. So you don't have as much time between when you installed that and when it fails. So if you have a temperature increase, that might be very close to failure. So you wouldn't have the time to maybe get in the part you need, get it on your maintenance plan, and get your PM scheduled. So vibration monitoring is one of the key techniques to push you further into giving you more heads up before something happens. So with that, when we do have those unplanned downtime events, we are an electrical safety company, so we definitely take worker safety seriously. And so when we have that unplanned downtime, it can cause maintenance workers to maybe cut corners, try to work a little bit faster to get it up and running, because there's a lot of pressure on them when the line's down. So when we have a planned downtime, on the other hand, you can go ahead and schedule out all those activities, have a much more organized shutdown, and be able to take the time to do all the right steps to get everything back up and running to reduce the potential for workplace injuries. So with that, let's go ahead and have Isabel introduce some vibration monitoring methods.
Yeah, so several ones we want to list out. Starting with the most traditional method you might be familiar with is typically you have a maintenance schedule set up depending on the equipment you have and how critical it is. You might have at most once a month technician that goes on site and with a portable vibration test instrument, and then checks each individual machine. But most likely you have once a year-ish maintenance on most of your equipment. So that's for the first basic methods. Now, Bryce, you're going to talk about the PLC-based one?
Yeah, absolutely. So with the route-based ones, that also requires a really skilled professional to do that work. So you have to have either someone on staff who has those routes, and some facilities are lucky enough to have a team that is dedicated to this, but many don't, so they have to contract that out. So having the skills on site is really a requirement with that route-based system. So when we look at kind of some of the other options, so we have two kind of other options that are more of the wired approaches. So you have a basic PLC integration, as well as the high-end systems. We're talking Rockwell Dynamics, Bentley Nevada, those type of systems. So with the basic ones, it's typically a single-axis accelerometer that is giving an overall signal. So that's usually 4 to 20 milliamps, 0 to 10 volts that you bring into an analog card on your PLC or something like that. These do monitor. It's just there is a lot of work to set those up, from being able to cable everything in. You might have to do new drops of power and Ethernet, and set up everything to where it's closer to the asset you're monitoring. That's a big cost on top, as well as now we have RMS values. What does that mean? If you don't have a vibration specialist on site, you can be getting the overall signal, but you don't necessarily know how to use it. So the other end of that is kind of your high-end wired system. So those are going to be on your very expensive equipment. So if it's the equipment that when it shuts down, you know the downtime cost per minute, and it's in the thousands and thousands of dollars. That's where those high-end systems really come into play. So they're going to be on the core of your plant. They're not going to be on your balance of plant assets, just because it's cost prohibitive to put that in, but it provides really good data. You can get full-time waveforms, FFT analysis. You can get different things like that where there's analytics on top to point out what type of failure you might be seeing.
Right, and so there are similar systems that are IoT-based. There are all sorts of IoT-based systems that report all their data to the cloud. And some of them are, just report the overall RMS value, and then it's up to the user to do what they want with it. And then you could also report the mean velocity value, and there's all sorts of different kinds of level processing after that. Rather than just showing the value itself. And then something else to consider is all accelerometers might have varying bandwidth, also bandwidth depending on the axis. Some are just focused on one of the three axes only. So there's lots of options out there to pick from.
Yeah. So what does GraceSense offer? There's a lot of different options out there, so where do we sit?
Yeah, so GraceSense offers a comprehensive banded analysis is how we call it. So we monitor vibration across a wide spectrum, and then we split the spectrum into different frequency bands, and then we report the vibration that this band contains individually. Our system is very configurable. You can enable whatever band you want. We'll go over the bands in details in our demonstration, but I just want to say that we can target certain bands. There's bands that are specific to some type of equipment, and we can configure the frequency at which we want to monitor from a minute to 6 hours, and so. That's what we specialize in. Now we would love to know what you guys are using, everybody watching. So you should have a poll question coming up soon that'll ask you which vibration monitoring methods do you use at your facility. So options are the ones we just discussed, the periodic route-based that I mentioned earlier, where you just come with an instrument and tests periodically on your equipment. You have the basic 4 to 20 milliamp I/O board on your PLC that Bryce talked about, and then your fancy high-end wired full analysis option, or you could have the IoT, the IoT technology versions, or maybe you don't even monitor vibration at all. So we would love to know that. Nick is going to collect your answers.
And so the big thing here is that, there's a lot of different things in the facility, a lot of different types of equipment. So you might have a combination of all of these, and probably most of our customers do. So, those high-end wired systems probably aren't going to have them everywhere. If you have route-based, you might do that on most of your equipment, but then you have an IoT system on some of your more critical ones. So there's going to be a whole plethora of different answers, and we're just trying to figure out where you're at in your vibration journey and where the kind of industry is sitting today.
All right, so results are in. 39% are doing periodic route-based with a portable test, and 31% basic PLC sensor. 19% are using a high-end wired solution. 17% are using an IIoT-based vibration monitoring system, and 35% answered none of the above.
Wow, so we have a mix, really a mix of everything. So that's nice. So I'd say let's go ahead and move on to our demonstration. So we have pre-recorded that part for sake of simplicity. So the goal is to set up this system you see here on the table with this test motor from scratch and look at how you do the setup and how you monitor the data coming in on our maintenance hub. So we want to show you this piece, this hardware piece, and the screen at the same time. So let's say let's go ahead and get that launched.
All right, so now Isabel and I will go through and set up an example system here. So we'll take a look at what we have. We have a gateway here that collects data from our vibration and temperature node that sits on a motor. We have an example motor that's just a 1/4 horsepower here today hooked up to a VFD. So I'll go ahead and power on our gateway to where we can start to see data come in. So you'll see if you look at the maintenance hub that Isabel has on her screen that it's showing 0 of 2 active. As this gateway comes online, it'll become active, and then in the next couple minutes, we'll see the VBT come online, so our vibration and temperature node. A little bit on the hardware there. So it is a triaxial accelerometer. It has a magnetic base that we're using to connect to the motor itself. And it has a battery that you can put on there with 3 Torx head screws. So in about 3 years, if you're at 1 hour intervals, you can easily replace that in the field. Our gateway here is actually what we call a combo gate. So a combo gate it has a connection to our cloud. So the maintenance hub that Isabel will show. So that's via LTE in this case. We also have Wi-Fi as a available option. And then the other part is connection into Studio 5000 via an Ethernet IP connection. So that's our kind of control side. So you can have both of those in one unit, which is a unique feature that we offer. If you just wanted to have cloud only, you can do that. And if you just want to control only, you can do that as well. So with that, I'm going to go ahead and start up the motor. So we don't have any defect on there. It's kind of just a motor sitting on the table that we have clamped down. Later in the video, I will introduce a defect, or you can see what that looks like in the maintenance hub using an eccentric load kind of puck. So let's go ahead and get that started. All right, so now that we have it going, I'll have Isabel go ahead and walk you through the maintenance hub.
All right, so here we are on the hub. As we can see, the nodes that Bryce just plugged in already connected. So we have the first one, the part number, EIP, the serial number 1D0008. That's the cloud gate we have here. And the VBT that's sitting on the motor. So you can see all the details about it. We will go back and go over those channels in more details, but first let's get our system set up to start monitoring vibration. So we get into this vibration analysis page, and we are going to create an asset. So the motor on our table is our asset. I'm going to call it test motor, for example. You can pick what kind of motor you are dealing with here. I'll just pick, let's say, fan blower shaft. And you can pick what kind of vibration analysis you want. We have several options to pick from. For each option, you can see what bands are enabled. Or you can completely customize by using advanced VBT which bands you want to monitor. So you've got the XYZ bands for each axis. You have 8. Yeah, at 8. The overall subsynchronous, 1 times the RPM, 2 times, 3 times. You've got the bearing band, the low harmonics, and the high harmonics. And for each axis, you have got both amplitude in inches per second and frequency in round per minute. And we got additional bands here for special cases, the gear blade frequencies, but we're not worried about those for this demonstration. We will pick a basic analysis type. And so here's the other settings. You can decide how often you will sample data. Here for this demonstration, we'll pick 1 minute, and can enter the speed of your motor. 1800 is kind of our default value we'll go to, but this is customizable, and our acceleration range, depending on what amplitude of vibration you're expecting to monitor, you can adjust the scale. Here we will stay at 2 Gs. So now moving on here, you can see you can recognize the serial number of the VBT we have currently on our motor. And we get to decide where it's placed on the motor. So all you have to do is drag and drop to, I would say, right now it's sitting here on the motor. So this is the most accurate place it's at. And then additionally, you can adjust the alignment of the axes. So X, Y, and Z, how does that align?
Yeah, so the X, Y, Z, I'll show you on the motor here. So if you get close up, you'll see the X-axis runs with the length of the sensor. The Y-axis is on the short side, and the Z-axis comes out kind of through the battery. So the way it's set up right now is appropriate. So we're good to go with that. But that is key to, especially when we talk about defect classification moving forward in the future. We want to make sure that we can identify what axis the fault is occurring on, because that will help us determine what are the likely failure modes for that orientation.
Yes. Thank you, Bryce. The second one we have is the alarming. So for the overall band, those are the default values we are going to set. We have 2 levels, the warning alarm and the danger alarm. Our typical values, those the typical values we usually have?
So the values that we have here are all the different machine types that you saw before as Isabel was walking through have their own unique thresholds that are determined by ISO from all their various testing that they've done. So we're not reinventing the wheel here. We're just starting at a point where there's already a lot of data gathered. Let's use that to get a starting point, and we can adjust as we move forward. So for this particular fan asset, those are the thresholds that ISO said are appropriate.
Yes, so let's just stick with those example values. And as for the alarm settings, so we are going to, for example, have it send an email. It's already previously set up in the hub, so that if the data crosses any of those thresholds, Bryce will be notified by text or email.
Yeah.
So now I think we are all set with our asset. We just have to click save. Asset is created. And now coming back to our vibration analysis page, we can see our test motor is running, is currently online, and all is good. It's a healthy motor.
Yep, so it's all green here. If we go to the ellipses up there, we can get into a tighter view of it. So click down below, Isabel, right here, and then go to the view. So this view page gives us, a better detailed view of what's going on with this asset. So if we were to expand the position 1 that it's, or position 2, sorry, that it's on, we can see these are our current values. So let's go ahead and I'll turn off the motor. And now I'll introduce our defect. So once again, it's a kind of a puck that we have off center to where we can get an eccentric load. So I'll put that on now. All right, so now we've started the motor back up with that load.
All right.
You'll notice we have all this foam under our cloud gate and the laptop because of the shaking it is doing on this table.
Yeah.
So
while this is running and data is being collected, let us go back to the main dashboard. So the diagnostics has the voltage the cloud gate sees, and then two different signal strengths. As you can see, the first cellular is the LTE signal strength it sees, and the wireless one is the Zigbee communication to its VBT. And similarly, on the VBT side, you can see the signal strength that it sees from communications with its parent, the combo gate, and the battery voltage, and a couple more diagnostic channels, error codes, and boot up values. Now, if you expand the vibration section, you can see that data is being reported on all of the channels that we have enabled previously when we were setting up the asset. So as you can see, it's mostly green so far. Currently we're picking up a little extra vibration in the y-axis. This is just the most recent value. If you hover over this trend icon, you can see when was the last time a data point was received. But if you'd like to go into further details, let's see, we can pick the overall channel, for example, and see a time history of that specific data channel. Right now, we just turned it on, and we only have a few data points, but you have different views where you can zoom in into a specific time slot quickly. Additionally, you can add extra data channels to this plot, up to 5. So let's see, we have a Z. It'd be interesting to add the y-axis overall, x-axis. Let's just keep those 3 for now. And then drag and drop. Not drag and drop. Zoom in to a specific point, and you can hover over to see each individual point. Right now I selected the amplitude, so it's in inches per second. And as data is being collected every minute, you can keep on refreshing this page and see the new points come in. So here in a little bit, we should start to see this data go up the next minute. So while we do that, while we wait, oh, here it comes. You start seeing a lot more red. So specifically, we've got extra vibration in we're up to 1 inches per second on the y-axis, and you can see that reflect on the overall band that includes all the other bands. And it looks like a lot of this vibration is also in the subsynchronous band. Was that expected from the puck you added?
Yeah, with the amount of vibration we're seeing, it's definitely going to travel across some of the other bands as well. So let's go ahead and take a look at the asset view while I go ahead and shut off this motor so we don't have to keep shaking around.
Yes, please. Back into this page. So you can see in the asset view, things have turned red.
Yep. So that basically, you have your little indicator there of your health at a quick point of view, but let's go ahead and dive in and take a look at what we've seen.
So going into the details of what happened. So clearly the vertical axis will be our Y, where we were seeing elevated values when we were on the dashboard. And you can see here those 1.06 inch per second are showing up as way above our danger threshold level?
Yeah, let's go ahead and now that Isabel's run through some of the Maintenance Hub stuff, let's take a look at what we do to set up, now that we're set up in the cloud, to get set up in our PLC.
All right, so I'll let you do that.
All right. All right, so the other piece that you're not seeing here is we do have a Compact Logix PLC, so a Rockwell PLC that's across the building, and we're all networked in. So there's a few steps that we do from the Maintenance Hub in order to get this set up. So let's go ahead and go into, the first thing I'm going to do is go into my node settings, and I am going to change the configuration source. So right now, basically, the cloud is telling this combo gate how to react and how to respond to different nodes, trying to check in, things like that. So we're going to change it to where the control gate is actually the master. So let's save. And last thing I need to do is I'm going to go to my control gate configuration page. So here I can see we have, this is our combo gate that has one node under it. Larger systems, you might have 5, 6, 7, 8 nodes per gateway, just depending. Up to 12 is kind of our limit with our normal setup. If you have additional vibration channels or less vibration channels, you can get more or less into that gateway. So just keep that in mind, and we're happy to walk through with our customers to discuss the application and what that means as far as kind of how many nodes you can have talking to one gateway. So we don't have any unassigned. We're all set up here. Let's go ahead and export our AOP XML file. So there are some other files here. So there's a memory map file if you just want to see kind of what that data looks like. Really important in a Modbus application as well, because that's going to be what you use in order to set up all of your registers. There's a tool for Modbus integrations. There is a EDS and L5X approach that we used to use, and some of our customers are still using, but our custom AOP is what we're using today. So let's go ahead and export that file. So you'll see it popped up down here, and so I should be able to use that when I start Studio 5000. So let's dive into Studio 5000 and start a new project. And we are going to name this IIoT or PLC webinar. And so a key thing here is you'll notice that I am on Studio 5000 version 35. So this is the new one that Rockwell released back in November, and this is the version that has our AOP pre-installed. If you're using an older version, like many of our customers are, you can reach out and we can distribute that AOP to you, and you can ingest that and bring it into your Studio 5000 environment manually. But if you do upgrade to version 35, it will be automatically there. On our Compact Logix, I know we don't have any modules installed. So let's go ahead and finish the setup. So it's going to go ahead and load in here so I can start to set up like any other project. So most of our customers are familiar with kind of how Studio 5000 works, because we are very heavy working with our Rockwell customers through our Rockwell distribution. So anyone on the plant floor who's familiar with this will be able to easily integrate our system in really about 10 minutes maybe to get tags flowing. So that's very fast. There's a lot of unique things we do with that AOP export that I just did. So our memory map is not a static one. So if I add in 3 more VBTs to this network, I am going to have a new memory map for that. And if I have, there's panel mount nodes that we have so that they can bring in different types of sensors, like 0 to 10 volt sensors. So if you wanted to get a CT or 4 to 20 milliamps for pressure or flow, you can bring all those sensors in, and it makes a unique memory map that we're able to export as an XML file that we can bring in, so you're not manually mapping all those tags. So that's something unique that we did, and why the custom AOP is really an important part of this integration. So let's go ahead and first step here is going to be to add our device. So this will be looking for our control gate out there in here. So, if you're in the general catalog, you can just search for Grace, and you'll see right there we have our device. You're going to want to go ahead and add to favorites just to where the next time you use it, it's nice and available. So let's create this device. So I'm going to name this one. We'll do webinar control gate. And I know I have this at 10.0.75.12. When it ships from the factory, it is 192.1.168.60. So you'll want to change that to whatever you want to use within your, your different networking scheme. So next step here is actually bringing in that file we exported. So this is going to tell this control gate how to interface with the PLC as well as all the nodes in its network. So let's go ahead and browse for that. And there it is right there. So we'll click OK, and we'll say yes, and OK again. All right, so our device is now created. So there are some data types that it automatically will create with that if I click on the right one. So there's these module defined data types down here, all these GT colon. So those are all the different kind of data types that we're using and are automatically integrated when you import that file. So if we go up to our controller tags, we'll see our webinar control gate device. So here, if we go in, we can see these are the configuration tags. So we have system level ones that dictate wireless channels. So for our Zigbee, how many nodes there are, what types they are, that type of thing. And then we have configurations for our control gate and our nodes. I'll go ahead and get this online. So we'll go ahead and set our project path. And so I believe mine's at 10.0.75.10. So let's find that. There we are. 10.0.75.10 and go online. So it's going to have me download since I have a new file for the device. So we'll download that to the controller. All right. So we'll change it to remote run so I can see everything happening. So yeah, let's go ahead and look at some of the data tags. So let's go ahead and Isabel, if you wouldn't mind rebooting that gateway. So rebooting the gateway will establish the new communication with the PLC with the open forward to give it all the information it needs in order to talk to the devices. So let's wait for that to come in. We'll go to status. So we'll see we have our first, there's a 24 volt that we're supplying to this, but it is then stepped down to 5 volts inside. So we're looking at that regulated voltage. And then if we go in and we'll look at here's our VBT. So we'll see if we have any data from that yet, and we do. So perfect. So we can see, okay, we have 3.69 volts, which is very good for this battery cell. And surface temperature readings, RPM, and then you can go in and see all of the different bands that Isabel showed you in the maintenance hub. So it's really a direct reflection of what we're seeing in the maintenance hub. So from here, any controls engineer can build out what level do we want to have alarms, what screens do we want, how do we want to utilize this within our system. So it allows our customers who really live and breathe in this Studio 5000 environment to be able to get all that information there. So with all this data, we can go ahead and set up those alarms and alerts. The maintenance hub is nice because it's all done for you. So as long as you select the machine type you want, then you can send out that alarm, that alert via text or email. This just allows you to do it a different way. So Grace would be happy to share those thresholds with you, give you a good starting point to put into into your program, or you can let it run and then kind of evaluate after running for some time.
So could you go in and change a setting on Studio 5000, or do you have to regenerate the new XML file?
That's a good question. So if we changed a small thing, if all we did was want to change how fast the unit's talking or something like that, that can be done very easily within the config registers here. If we did want to add a node or something like that, then we'd want to export a new file because we're adding in tags and those locations might change slightly, and we're appending basically to the end of it with our new VBT. So yeah, and there it came back online after we did the reboot. So the gateway basically, it got the new configuration from the PLC and kind of rebooted and applied that so it could readopt this now that we switched control as the source here, which I suggest for most of our industrial customers who are integrating this to have the control as your source of truth and what's telling the gateway how to react, to where if I do make a change here, it does impact the gateway. If you didn't do it that way and you made a change here and it was set to CloudGate, being the maintenance hub would be the master, then it would not be reflected. So it's just kind of a trade-off on which one do you want. Do you want to go into the maintenance hub and make all your changes there, or do you want to do it through your Studio 5000 environment? So I think that kind of wraps up what we wanted to show today. We kind of went through and showed you all the hardware, went through our maintenance hub and showed up all the different features and what a fault looked like there, as well as how to get started with getting tags flowing in your PLC. So, all right. Well, Isabel and I appreciate you tuning in. Thanks for watching, and we'll cut back to the live webinar. All right. Well, thank you for staying with us, everyone. So we're going to go ahead and wrap up. So kind of saw what a IoT system looks like, getting that set up and getting data flowing, which is going to be unique to each IoT system, but it's going to have a similar set of rules and things you do in order to get data moving. We also looked at how to integrate that in the PLC, which is unique in the way that Grace approaches it. But when you're talking about any of the higher end systems or your basic wired systems, they would operate in a similar fashion.
Yeah, so I hope this was helpful for you guys. Something I really like about the system is the alarming capability is really cool, where you can just pick what works for you. You can have text alerts or email alerts set up if you're more of a sitting in the office most of the day. It gives you a peace of mind and you stay on top of things. And you could have alerts set up on your HMI applications that monitors the tags of the vibration channels. If that works for you, if you're spend most of your day on a plant and want to have a visual indicator. So yeah.
Yeah. So I think you touched on a key thing there, in that it's not you can have both options. So some people in the plant, say operations, might really like having the ability to log into an easy-to-use software like the Maintenance Hub or a different solution out there. But a lot of the maintenance people, they would want it on a HMI while they're walking around, being able to see that, hey, vibration's high on a specific asset and be able to address that. So I think that's kind of a key thing, is having both. And some facilities just the cloud is not an option. There isn't an ability to let data leave their four walls. So they like having an ability to have it in their control system where they can control the data and do what they want with it. So with that, we'll go ahead and kind of wrap up, and Nick here will go through some of the questions you guys have asked. And so if you have any questions, now would be the time to type them in, and hopefully we can address all of those before we sign off.
Yeah, I think we have about 10-15 minutes left.
All right, so the first question is there an option to ignore motor startup transitions, which may experience harmonics at the motor ramp as the motor ramps up?
That's a very good question. So there are might be some systems out there that accommodate for that in different ways. Ours doesn't necessarily do anything in particular to accommodate for that. this is typically on a device and it samples once an hour. So if it happened to wake up when that startup was occurring and do its sampling, you will see potentially a higher one at that point. But when the next time it samples, it will have a more normal type. So when you look at it over time, you'll see that was more of an anomaly than it was, a steady increase. That's really what you're looking for, is it to go from healthy and gradually, move towards an unhealthy condition and being able to intervene.
All right. How close does the gateway need to be to the VBT? Is there a wired option for longer reach?
Yeah, I'll take that one. Good question. Our VBTs can be up to about 30 meters, that's about 100 feet, line of sight to their parent. Obviously, the length matters, the RF condition of where you are and all the machineries in between matter. As for the wired solution, I'll let you answer that.
Yeah, so we do have the ability to cable out as well via either the gateway or the VBT using coax type cabled SMA connections to get you either you have one remote VBT that's off to the side that you'd want to bring in. Maybe it's under guarding and you want to get that out from under the guarding because a metal box around a wireless system does not perform very well. So we want to eliminate that Faraday cage. Or the gateway itself, if you had it in one location where you already had power and Ethernet ran, and you want to then just pipe out one coax cable to go and pick up those VBTs, you can do that. So it's really, it can get around some of those RF issues. And Grace does, when we go to deploy, we'll do a site survey. So we go out there and we say, where are all the nodes that we're looking to deploy? Where would we want to have gateways to have the correct number of gateways with good coverage to where we can have a very reliable system that performs moving forward. So we don't expect our customers to be experts at that, so we definitely want to lend a hand.
So I think this was asked during the Studio 5000 demonstration. The question is, can we do the same with TIA for Siemens?
Yeah, it's a good question. So the only really tight-knit integration we have is currently with Rockwell and Studio 5000 using Ethernet IP. We do have Modbus TCP as an option. So you could do a Modbus integration and then would have to do your register mapping from there. We are looking for customers who do have those applications that we could maybe build something with them in those systems to where we can better support customers moving forward, but it does not exist at this time.
Okay. Does each motor need its own control gate?
I'll take that one. No, not at all. We can have a group of up to 12 VBTs reporting to the same parent. And then those VBTs can be placed anywhere in the motor. As you saw in the demonstration, you can have like multiple VBTs monitoring one motor, but you can have, you can create multiple assets, and each asset will include whatever VBTs are on there, and they all send their data to a common parent. If that makes sense for your application,
Yeah, so 12 is the kind of rule of thumb number with a control gate type application. Because that memory map, there is a size limitation. So that's kind of where the 12 number comes in. If you're doing cloud only, it's really only limited by that range that we talked about before, the 30 meters line of sight. That type, you could, if it's just going to the cloud, you could have as many really as you can get in that area. So yeah, within reason. I've
30.
Yeah, we've easily had 30, but I could definitely see doing more, especially if we're talking 1 hour intervals.
Right.
The data bandwidth there is going to be pretty low.
All right. What tools do you offer to help determine the best vibration threshold for specific applications?
Yeah, so I think the way we go about it is we generally like to have a baseline period before setting anything up to where we don't, have either nuisance tripping or, have ineffective alarming. So we like to let it run, but the ISO thresholds are really where we start. So that's our our starting point, and then we can tweak it from there if we determine that we need a higher threshold because it's maybe it's just baseline's a little higher than other equipment, or it's not as rigidly mounted, something like that. So we definitely work with customers though. Like we're very tight knit on our applications to make sure that you guys have the support you need to get your system set up and running, and then once systems are set up, they're relatively hands-off. Once it's all up and running, you have everything set up. Usually it's just kind of more maintenance, reviewing the data occasionally or getting in there when there's a notification of a problem.
Okay. Can you extract the raw time waveform data from the sensor?
Yeah, that is a very good question. So that is not a commonly offered thing in the IoT space due to the bandwidth. We are definitely entertaining that at offering that at some point, but the intervals would be limited to where when you have a problem, you could pull it, say, to get a full-time waveform, but currently not offered at this time in our system.
Okay. Are you alerted in the maintenance hub when your batteries are low or wireless signal is weak, for example, using the green, yellow, red color scheme?
Yeah, absolutely. When we showed you how to set alarms on vibration data, but of course you can do the same thing and set alarms on your battery voltage channels if it goes down a certain level, or RSSI, and the thresholds are completely customizable.
Yep, there are battery reports you can run as well. As when you're looking at that asset view, each node under there has its own kind of diagnostic health indicator. So when we looked at the bands where you saw the vibration, up above it did for that node, it had its RSSI value as a fan indicator, green, yellow, red, and then it had battery voltage as once again, a little indicator, green, yellow, red. So, we're definitely tracking that, and because that is an important part of a system, is obviously knowing before it dies to get your battery replaced, or if it's having trouble communicating, maybe there's something we can do to improve that.
All right. What extra information can you receive on the VBT2 versus the VBT1?
Good question. So the difference between the two is the VBT2 has a higher end accelerometer and has a higher bandwidth. So the VBT1 can go up to 800 hertz, but the VBT2 has a X and Y axis to 4600 hertz and Z axis 22,000 hertz. So then you will get, I would suggest using the VBT2 if you're targeting one of the higher frequency bands to get better accuracy on those. But if your application is just monitoring the overall level, or you have a low frequency, low RPM motor, you would pick that one. Otherwise, all of the settings are the same. The way you configure one or the other on the hub is exactly the same.
Yep. So common applications are really getting into high harmonics with the VBT2. So you get early stage bearing wear. So you get a little more time, heads up that you're having some issues out in the harmonic realm. And then there's also really gearbox applications. So if we're talking about a motor spins at 1800 RPMs and it has 25 teeth on that that input shaft, that would be a multiple that we'd want to monitor. And then you actually take the multiples of that. So both 1 times the gear count, 2 times, and 3 times are what you would monitor. So that's definitely a key part of where the VBT2 comes into play.
All right. Is magnetic mounting the only option? How do you mount to alloy framed motors?
No, it's not the only option. We have 2 more. We can either directly epoxy the VBT on your motor, kind of a permanent solution, or you can, we have that fin mount option that maybe you can elaborate on.
Yeah, so there's a few options. Most of the other ones involve epoxy, or you could do a direct stud mount as well, using a 1/4-20 stud. But yeah, the fin mount would be just in the fins. You'd have a mount that we put in epoxy, and then you can mount our VBT to that. So there's a few different options. Definitely on, if it's not magnetic, we're going to have to do a different solution. But a lot of our customers, at least for kind of starter kit systems, beta systems, we do typically do the magnetic option, and then we on the larger deployments, we can make an adjustment on what type of mounting makes sense.
All right. What is the IP rating on the sensors?
Yeah, they're IP66.
Okay. That looks like that's about it, guys. Do you have any closing remarks you'd like to give now?
No, we appreciate everyone joining us today, and hopefully you found some value in this and can see some of the options out there that maybe the IoT was something that you hadn't looked into yet, but hopefully this gives you a reason to take a glance.
Yeah, if you've got any other further questions, feel free to contact us. We'll be happy to answer or explain anything you need. And yeah, thanks again for joining us today.
Yep, thank you.